Here we have the graph of the function y equals 4 minus x squared. Because it's a quadratic function, its graph is a parabola. Because the x squared term is negative, the parabola is inverted. Another thing about this function is that it is symmetrical about the y-axis, and that's easy to see from the form of the function. Like if we were, say, getting f of minus 1, if I call this function f of x, f of minus 1 is 4 minus 1 squared, but that's just the same as 4 minus plus 1 squared. So f of minus 1 is the same as f of plus 1, so you know we have this symmetry. We get the same value for x as we do for its negative. So if x is minus 1, we get the same value for x equals plus 1. Now, we also have the graph of a straight line. There are no x squared terms or y squared terms in this, and neither do we have terms of the form x times y. So this thing is a straight line. We see that it cuts the graph at these 2 points. Now these are 2 points that we will be interested in getting if we want to get the shaded area. So let's start by getting these 2 points. Well, say the x value of this point has the property that the function has the same value. So this will equal, well, we need to first of all rearrange the equation of the line to make y the subject. So y is minus 2x plus 1. Okay, so whatever this value of x is, if we plug it into 4 minus x squared, we'll get the same answer if we plug it into this here. So we want both of these to equal each other. Okay, so at this value of x, both of these functions will have the same value. So we set these equal to each other and solve. You could give these names if you like. You could call this f of x, as I said earlier, and we could call this g of x. So at this value of x, we see that f of x will equal g of x. And it's the same for this point here. Okay, f of this value will equal g of this value. So we put 4 minus x squared equal to minus 2x plus 1. Now we need to solve this equation. We've got an x squared term and an x term, so we can't just bring x to one side, numbers to the other side. We have to get this into the form of a quadratic equation. So we're going to get 4 minus 1, which is 3. So I brought everything to the left hand side. It's convenient to make the x squared term positive, although you don't have to, but I'll make it positive by multiplying all of this by minus 1. Now let's try to solve this quadratic equation. Let's see if we can factorize it. So if I put minus 3 here and plus 1 here, then it will work out, you know. We get minus 3 at the end and we will get minus 2x in the middle. So we have a product of things giving us 0. So the only way that can happen is if each factor is 0. So if x minus 3 is 0, we get x equals 3. If x plus 1 is set equal to 0, we get x equals minus 1. So these are the 2 solutions of this quadratic equation. So these are the 2 values of x for which f of x equals g of x. So in other words, f of 3 equals g of 3, and we see that f of minus 1 is also equal to g of minus 1. Okay, so we have the x values of these 2 points. We don't have the y values yet, and it turns out that we don't actually need them, because our limits of integration will be from minus 1 to plus 3. Well, for some of the integrals that we do, but we've quite a few integrals to do here actually. Let's get this point here. Well, this is a point on the curve y equals 4 minus x squared, but y value is 0. So we put 4 minus x squared equal to 0. Okay, so we set y equal to 0 because it's a point on the y-axis, or sorry, the x-axis. So y is 0. And if we solve this, we get x equals the square root of plus 4, which is 2 values, plus 2 or minus 2. So clearly this one here must be plus 2. And this one is actually minus 2, but we don't need that one. So we can leave that one out. Let's start by getting the area under the curve from -1 to 2. We have a vertical line at -1 hitting the curve. At 2 we have no vertical line because the curve crosses the x-axis at 2. So we're going to integrate from -1 to 2 to get this area here, which I'm showing in this purplish colour. So we're integrating 4 minus x squared, that's the curve, dx, from -1 to +2. If we integrate 4 with respect to x, we get 4x. Integrating minus x squared gives us minus a third x cubed. So we plug 2 in for x, and we subtract this expression with the lower limit -1 in for x. Okay, so we get 4 2s are 8. We've minus 8 over 3 here. We've -4, and the minus gives us +4. Inside here we have -1 cubed is -1. By minus a third is plus a third. And then we have the minus sign giving us minus a third. Okay, minus 8 thirds minus 1 third is minus 9 thirds. Minus 9 thirds is minus 3. So we have 8 plus 4 is 12. 12 minus 3 is 9. Next we will get this green area. Now to do that we need the coordinates of this point here. So this is the point where the line y equals minus 2x plus 1 cuts the x-axis. So first of all I'll find that point. So there's the line. It cuts the x-axis when y is 0. So the y value of this point is 0. So we just solve this equation and we get minus 2x equals -1 or x equals a half. So this green area here under the line can be found by integrating from -1 to plus a half the equation of the line, which is minus 2x plus 1 times dx. So this is straightforward. Oops, sorry about that. If we integrate minus 2x squared, we add 1 onto the power to get 2, not 3. And we divide by the new power. So minus 2 divided by plus 2 is -1. If we integrate 1 with respect to x, we get x. So we have minus a half squared. Well, that's minus a quarter. Plus a half. Then a minus sign. And here we have minus 1 squared. That's -1. Then we plus -1. That's another -1. So we minus quarter plus a half. That's plus a quarter. Then we have minus 2, that's plus 2, so we get 2 1/4. Now we could have got that area by looking at this right angle triangle here. We're getting the area under a line, so we don't actually have to do any integration. So in this right angle triangle, the base runs from -1 to plus a half, so the length of the base is 1 1/2 or 3 halves. Now what about the height? Well, the height of this rectangle is the value of the function at -1. Well, the value of either function at -1. So we could get, say, g at -1 by plugging -1 in for x here in the equation of the line. So that's going to give us -2 by -1, which is +2. Plus 1 is 3. So the height is 3. So then we could multiply the base by the perpendicular height. 3 over 2 by 3 is 9 over 2. Divide that by 2. To get 9 over 4. Now 9 over 4 is the same as 2 1/4. So that would be an alternative way of getting the area between a straight line and the x-axis. So to get this black region, we take the purple region, which is 9, and subtract off the green region, because the purple region extends from -1 up to 2. Okay, so the purple region is overlapping with the green region. And that's 9. So 9 take away the green region. 2 1/4 is 6 3/4. Now we have to get the lower part of the shaded region. So how do we do that? Well, again, we have to consider two regions. One region, which I'll indicate in this color, extends from -1/2 to 3. And that's a region between the x-axis and the straight line, y equals -2x plus 1. So we have to integrate from +1/2 to 3, the line which is -2x plus 1 dx. Now, rather than doing the integration, I will use the fact that we have a right angle triangle here. I'll get the base of this right angle triangle, the distance from plus a half to plus 3, well that's 2.5, and multiply it by the perpendicular height, which is this distance. Well, this here is f of 3, okay, or g of 3, doesn't matter. So we plug 3 in for x and we get 4 minus 3 squared, 4 minus 9. 4 minus 9 is minus 5. Okay, so if you were to do this integral, this is what you get. You get half this side, which is 2.5 by minus 5. Okay, if you work this out, you'll get minus 6.25, and or if you integrate and plug in your limits, you'll get minus 6.25. So notice that we get a negative value for the integral. That makes sense because the line is below the x-axis for the interval x equals a half to x equals 3. So the value of the function is negative for x running from plus a half to plus 3. So this thing is actually negative in this interval, plus a half to 3. We always assume that dx, by the way, is positive. So the whole thing is we're integrating something negative. That's why we get a negative answer. The last integral that we have to do is the integral from 2 to 3 of the curve, which is 4 minus x squared. Okay, so we want to get this green region here, the area under the curve from x equals 2 to x equals 3. We have to take that green region away from the purple region to end up with the other shaded part, the shaded part that's below the x-axis. So here we get 12 minus a third of 3 cubed, that's 9, minus 8 minus or plus 8 thirds. 12 minus 9 is 3, 3 minus 8 is minus 5, 8 thirds is the same as 2 and 2 thirds. So we end up getting minus 2 and a third. Again, we get a negative result because 4 minus x squared. 4 minus x squared is negative for values of x running from 2 to 3. The graph is below the x-axis. Now we need to put everything together. Now I will just take the areas rather than the values of the definite integrals. The definite integral could be positive or negative, but if we're just dealing with area, well, we just want the magnitude of all the quantities. We want all the quantities to be positive. So let's get this shaded area here. So I'll indicate this in black, like I did the other one. The other one was indicated in black. That was 6 3/4. Okay, to get this one here, well, we take the green area, which is 2 1/3, from the purple area. The purple area ran from a half to 3. That was 6 1/4. So we need to get 6 1/4 and subtract out the green area, 2 1/3. Alright, so working these out, you can get a common denominator of 12. So we have 75 minus 28. So you'll end up getting 3 11/12. So to get the answer then, we take 6 3/4, that's the shaded area above the x-axis, and add on to it the shaded area below the x-axis. So getting a common denominator, 3/4 is the same as 9/12. So we 6 3 is 9. 9/12 plus 11/12 is 20/12. So we get our final answer of 10 2/3. Now there is a quicker way that we could do this question. Notice that the curve f of x is above the line g of x for values of x running from -1 to +3. Okay, f of x is greater than g of x for all values of x in here. The curve is above the straight line. So that means that f of x minus g of x is positive. Now actually f of x minus g of x will be the length of a vertical line at x. So x is some positive number, well, it's some number on the interval from -1 to 1, so I'll just make this a bit easier to see. So let's suppose x is this value here. Well, then f of x is some positive number. G of x will be some negative number, of course, say for this x here and this part. Well, if you work out f of x minus g of x, you'll have the length of that line. So the y value of this point minus the y value of this point will give you the length of the line. And we can do that for all values of x along here. So for example, if x is here, then f of x minus g of x will be the length of this line here. Okay, so that's f of x, that's g of x, and there's x. And you can imagine summing all these vertical lines from x equals -1 to x equals 3. Well, that's just the integral, and we integrate with respect to x. And we have to integrate from -1 to 3. So f of x is 4 minus x squared, and we have to subtract g of x, so that's minus 2x plus 1, so that's plus 2x minus 1. So I'm just subtracting this from 4 minus x squared. So simplifying a little bit here, we get this. Now this is a straightforward integral. If you calculate this, you'll get the same answer as before, 10 2/3. So this is obviously a much quicker way of doing it, although it relies on concepts that are a little bit beyond the course. So don't worry too much if this doesn't make sense.